Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at UDP Communication. We'll be discussing UDP low overhead versus reliability, UDP Datagram Reassembly, and then finally we'll take a look at UDP server processes and requests. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. UDP does not establish a connection. UDP has a very low overhead. And what we mean by that, it doesn't establish that connection. It doesn't have to have a header. There's no network management that happens with it. But it does that at a cost of reliability. Because it has a low overhead, it doesn't have any of these control mechanisms built into the header, the reliability could be a little bit lower. And once again, that's why we use UDP for real-time data traffic flow. Voice over IP, video conferencing. When the destination gets in these segments, gets in these datagrams for UDP, it reassembles them in the order it was received. Because of how data travels through the network, these different datagrams can arrive out of order. When they arrive out of order, they're reassembled in the order they're going to get. Here, our graphic shows us that we've sent out datagrams from our source, datagram 1, 2, 3, 4, 5, 6, but the source, it received them in different orders. It received 1 first, second it received 2, then third it received 6, fourth it received 5, fifth it received 4, but it didn't even receive datagram number 3 at all. It reassembles them in the order in which it was received, and it doesn't wait to get anything retransmitted back. It gets data across the network a lot faster, but it's not reliable. You don't get the correct message, and you may not get the message in the right order. UDP server applications are assigned to well-known hosts. Two of these typically here are DNS requests and radius requests. Radius is a form of authentication. And what these do is they send these requests to the server. The server sees these well-known port numbers and it sends it to the server assigned to that port number to get processed. Here we have two examples using the DNS and radius for UDP. Down here, client 1 makes a DNS request. It makes that request on port 4950. It sends it to the server. Once again, there is no confirmation, there is no information coming back. And what it does is it makes that request on port 53, that the server receives it on port 53, while the client said, okay, it came from our source port number 49152. Because it's waiting for that response on 49152, the server takes it, flips the source and destination, ports around again, sends it back to the client. The client is waiting on 49152. It then can process that DNS information. Same thing here with radius. It uses a well-known port number. The radius port number is 1812. It makes the request to that 1812. Radius processes that and then sends that information back on client 2, waiting to hear on that destination port, the one it picked in the dynamic port range of 51,152. It was my pleasure to provide you with this wonderful episode on UDP communication. If you like this episode and you got value out of it, please click the like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks for the CCNA. I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.